As indicated here, we've transferred one additional clip. I'm going to give this a start on 3. Ready? 1, 2, 3. Good. Now let's see if we can get that to work again. I'm releasing it a little lower than I should, maybe about this much lower than you can see on the screen. Ready? 1, 2, 3. 1, 2, 3. Now, we're not going to get another run with one clip transferred. Now I've transferred another small clip, and let's write number 2 here. Releasing on 3. 1, 2, 3. Okay, I counted about 3.5 seconds. Let's try that again. Of course, my count is very approximate. Fluctuates with time of day, mood, etc. Okay, let's try again. 1, 2, 3. Bad spot on the pulley. Swing the pulley a little bit, and naturally, the quality of the pulley severely limits the accuracy of anything we can get from this experiment, but let's do this. Okay, ready? 1, 2, 3. Not moving. Try again. Ready? 1, 2, 3. I think this pulley has wider fluctuation in moods than we do. Ready? 1, 2, 3. Pulley's not going anywhere, is it? Probably ought to get some WD-40 out. But since we're in the middle of this experiment, okay, we have one run with 2. Now I'm going to transfer another clip so that we'll have 3. And we'll pause the video for a second. We've transferred another clip. Ready? 1, 2, 3. Took about 5 seconds. I don't think we're getting very good data here. Ready? 1, 2, 3. Okay. And another one. 1, 2, 3. Clearly the pulley's confounding the experiment, but we're going to go on in a minute. The uncertainties introduced by the inconsistent behavior of the pulley can sort of be remedied by transferring bigger clips. The more mass you have, the less the little glitches in the pendulum, the less net effect little glitches in the pendulum are going to have on the ultimate result. So I've transferred one large clip in addition to the others that have been transferred. And let's see what happens. Now this will go quite a bit faster, but let's see what happens. Ready? 1, 2, 3. Okay, I got something a little over 2 seconds. Do that again. 1, 2, 3. Okay, that seems to be fairly consistent. Another large clip has been transferred. So here we go. 1, 2, 3. Okay, that might be a little under 2 seconds. Ready? 1, 2, 3. Now a third large clip has been transferred. Ready? 1, 2, 3. Once again, ready? 1, 2, 3. What we have here is a system consisting of constant mass. We haven't added or taken away any of the paper clips. The pulley is the same every time. The system is subject to the net force that's proportional to the number of paper clips that have been transferred. And the question is then, is the acceleration of this system proportional to the net force acting on it? To answer that question, we simply have to figure out the acceleration. Now, before you figure out the acceleration, you have to have a distance here. So let's measure the distance. It's 1, 2, just about 3 hand spans, 3 of my hand spans. Now that can be converted to centimeters, inches, miles. But in terms of the distance, which is 3 hand spans, and the time it takes to accelerate from this point to this point, figure out the acceleration for each number of paper clips and plot that versus the number of paper clips. If that plot turns out to be linear, and given the limitations of this system and the behavior of the pulley, I don't expect it to be all that linear, but let's see how close we can get. Okay, is that graph going to be linear?